Alright, so we'll continue with tutorial question 9 from chapter 3. What we have in the question is a car moves with velocity 2 meter per second, collides with another car which has the same mass. Okay, this is something that we have to highlight here. They say that the car have the same mass. As shown in figure 3.4, the second car is initially at rest, so the second car is not moving, does not have any velocity. After the collision, both car moves at 60 degree and 40 degree from horizontal. Calculate the final velocity of each car after the collision. So we want to find the final velocity of each car. Maksudnya velocity of car 1 dan juga car 2. Assume the collision is elastic. Okay, this is another key words here. Elastic means the kinetic energy must be conserved. Alright. Okay, so let us first look at the image given here. We have car 1 as car A, which has mass the same as the car B. So MA is equals to MB. Let us assume this as M. And then we have car A is moving with initial velocity of 2 meter per second and car B is at rest, so UB is equals to 0. After the collision, we can see that it involves angle here. Okay, however, due to the error in that image here, this is actually our VA and this is actually VB. There is error in the image presented here. So the upper angle here, 60 degree, belongs to our car A. So this is where your car A is after the collision and car B is at this bottom here after the collision with an theta of 40 degrees. So this lead us to know that this is a 2D collision. Maksud 2D collision here, you are going to have X component and Y component. So you have to resolve them along X component and Y component dekat sini. So kita akan ada summation P initial along X must equals to summation P final along X. Alright, begitu juga summation P initial along Y must equals to summation P final along Y. So we have two equations here, and also we also have another point here to be noted, that is they are undergoing elastic collision. Maksudnya kinetic energy mereka adalah conserved. So we basically have three equations here, and what are we looking for adalah what is this value of velocity A and velocity B is all about. Kita nak cari final velocity. So kita ada dua unknown. Ngam lah, dua unknown ada tiga equation. So usually if you need to find two unknowns, you must minimum have two equation juga dekat sini. So kita dah ada lebih daripada dua, so we can obviously find our unknown here. So we are going to start with the X component first. So what are we going to do adalah we are going to insert the equation first, MAVA along X only plus with MB UB along X is equals to MA VA along X plus with MB VB along X. Begitu juga you are going to have M1 along Y is equals to, this is U, maaf, MA VA along Y plus with MB VB along Y. Alright, so let us first look at the X component. So as you can see, your car initially were on the road. On the road ini adalah on the horizontal surface. So kereta ini tengah bergerak ke kanan. Kanan is associated to X component. So as you can see, initially the movement is only along X. Tak ada apa-apa pun. Kereta kita bukan bergerak di sini ataupun di sini. Dia tengah bergerak along X, lurus. Okay, so what are we going to have here is the mass A adalah M. U along X adalah this one because it is moving to the right here. So which is along X, 2 plus with M. Your second car is at rest, so 0. So equals to MA kita dekat sini adalah M. VA along X. So we know VA is an unknown here. Okay, kalau VA along X, dia duduk sini. VA cos 60. So I'm going to substitute VA cos 60 here. And then I'm going to plus with MB adalah M and then VB cos 40 pula. Alright, VB cos 40 because your VB is here. We nak VB along X. Dia akan jadi VB cos 40 here. Okay, as you can see, both VAX and VBX are along the positive x-axis. Maka dekat depan ni kita biar dia sebagai positif sahaja. Now what are we going to do is, we're going to end up with 2m is equals to cos 60. Boleh tekan calculator, so you can simply press calculator. Cos 60, tekan ada 0.5, so 0.5 m VA plus with cos 40, tekan calculator, you'll get 0.766 m VB. As you can see, both this term on the right has m, which is common between them. So I'm going to factorize the m out. Factorize 0.5 VA plus with 0.766 VB. Alright, so dekat kiri pula kita ada 2m. And then what I'm going to do is, I'm going to bring this m to the left dan saya akan bahagi. 2m bahagi dengan m, we're going to cancel them. You're left with 0.5 VA plus 0.766 VB. So apa yang kita ada dekat sini adalah 2 is equals to 0.5 VA plus 0.766 VB. This is my first equation. Kita ada dua unknown, memang kita tak boleh proceed. You're going to stop there and then you're going to look at your second equation. Your second equation comes from your y component. So I'm going to rewrite that. Summation P initial along y is equals to summation P final along y. MA UA along y plus with MB UB along y is equals to M1 V1 y plus with MB VB along y. Alright. Okay. So now we are going to substitute in. Before I substitute, let us look back at the picture. Initially, your car were only moving along X. Along Y tak ada pergerakan. Dia tak gerak atas bawah langsung. Dia tengah gerak ke kanan sahaja. So all the momentum along Y component for the initial part is going to be 0. Sebab kita tak ada pergerakan along Y component. You do not have any velocity along Y dekat sini. Dua-dua ni kosong. Ini kosong, ini kosong. So I'm going to simply write 0 terus. And I'm going to substitute MA sebagai M. VA along Y. VA along Y dekat sini. So this is my VA. Along Y is going to go upwards. So dia akan jadi VA. Sebab tadi dah ambil cos, sekarang sin 60. So I will end up with VA sin 60. Then I'm going to plus with MB adalah M. VB Y. VB turun ke bawah. So VB along Y akan turun ke bawah juga. So which is a negative ya. Negative VB. Kali ini dia akan ambil sin 40. Alright. So what I'm going to have here is sin 60. Boleh tekan calculator. Sin 60 you get 0.866 M VA minus dengan sin 40 tekan calculator. You get 0.643 M VB. So what I'm going to do now here is I'm going to bring this one to the left here. Sebab dekat kiri adalah kosong saja. So I'm going to bring this 0.643 negatif bawa ke kiri jadi positif. M VB is equal to 0.866 M VA. What is common kiri kanan adalah M dia dekat sini. So I'm going to bring the M daripada kanan sini ke sini. Dan saya akan bahagi. So we're going to cancel them actually. So you will end up with this one here. So jadikan salah satu subjek. Let's say I let VB as a subject. 0.866 divide with 0.643 bahagi VA. This one you can actually press your calculator. 0.866 divide with 0.643. Kita akan dapat 1.347 VA. So the value of VB is 1.347 in terms of VA. So now I'm going to substitute 2 into my equation 1. My equation 1 was 2 sama dengan 0.5 VA. I do not have the value for VA. Leave it as VA. VB adalah 0.766 VB. Saya substitute 1347 VA. Alright, then now you press your calculator. 0.766 times with 1.347. You will end up with Ini salin balik. 1.032 VA. And then you're going to plus with 0.5. You will end up with 1.53 VA. Alright, so 2 divide with this one, you're going to end up with VA kamu sebanyak 1.31 ms negative 1. So since you have got your VA, you can substitute this into your equation 2 to get your VB. VB akan sama dengan 1.347 VA. 1.31. Ini kalau lain. This one is basically this one here. Alright, awak substitute saja kat dalam sini. 1.347 times with 1.31, you will get 1.76 ms negative 1. So this is your VA and this is your VB for your car A and car B. Alright.